Oh my gosh. How long has it been? How long? I don't know. I think it's been since September. I think that was the last time. Definitely the last time I live streamed was like early September. But anyway, I think I've come to the realization that my intros may be a little too long. And so I'll talk about everything else later. But for right now, I'm just gonna get right into the code. Okay? So as you can see in the title and the thumbnail right in front of you, this is my own programming language specifically for matrix operations, right? Like dot product, stuff like that. Basically just linear algebra. And it's called Lala, right? As silly as it may sound. I kind of wanted it to sound cute. Lala stands for the linear algebra language, right? But anyway, let's actually just get into it right now and see what Lala looks like, right? So, of course, the project is in Rust. Now, I have two ways to use Lala, right? Very much inspired by Erlang and Python. Technically, Rust has a REPL, right? EVCXR, right? But anyway, so I have two ways to run it. We can do it like this, which is just a shell, right? All a shell. So if here we're gonna see everything in action right now. If I have this, right, this is my matrix. Boom, right? Let B equal A. B, boom, right? I have some commands that I've written. /dbg, it just prints out the environment, right, in case you want to debug anything, right, like see what's going on. Because if I say let A equal 4, 5, 6, 7 now, A should be changed, but I do not make a I think it's shallow copy, right? Like shallow copy is basically just making B be a pointer to A. I don't do that. I clone it, right? I actually just copy it over into B. Right now A is this. This is literally just printing out the hash map. I am going to make this prettier, right? I am just going to make it be A, and then I'm going to show it as an actual matrix, not how I have it represented as a 1D vector. And eventually I do want to add some functions into this. So I'm going to be printing out the functions in the environment as well. But let's not get ahead of ourselves. This is nice, but also what I wanted to do is show the other way we can run this program. We pass in the -c or -- compile flag, and let's run our examples. Let's run matrix.lala, right? And then if I print out this file, x is the dot product of m and n, and we print it, and then we print the transpose, and then we print the inverse of some other matrix, and then we print the rank of A, and then we print the determinant of that last matrix, this one, right? So I mean, that's pretty much it, right? For what we were doing here, today at least. One more command I wanted to show was actually a link, examples / let's link the matrix one. Now this is literally linking another file. It links all of the assignments, right? And when I add functions, it'll also link all of the functions, right? So here in this Lala shell, I haven't defined m, n, x, y, z, a, but if I just print A, boom, that's the inverse of z, m, n, x, z, right? I have all these variables because I've linked them. Whoa! What is that? Oh, that's just how it's, yeah, when I print it out, I print out the two decimal places. But anyway, that's it for the shell and the product. Now let's actually go through the code. This is another devlog. I'm not going to write the code step by step. That takes a while. So let's look at the devlog. Again, I'm using test.rs. You can go look at both of my previous videos, I believe, where I go into this more in detail. I'll just go over some changes right now in the parser generator. So originally I had like ref as a $sign. I don't know, I was having trouble remembering my own things that I made up. So I've just changed some to like the actual words. What have I changed? I've changed like the command things, right? So I have like a command here. It begins with a slash, and then it's a command, which is any ASCII alphanumeric code, and then followed by any number of parameters, which don't include white space. I mean, we saw it with the linking, right? Because I could do something like slash link a.lala, b.lala, in a folder, right? f/c.lala, right? That's pretty much it. I think that's the only thing I've changed in here. So let's go into main, right? Main, as we saw, it just determines whether or not the compile flag is present. If it's present, we don't run the shell. Otherwise, we do run the shell, right? I guess I'll show you the shell because they both use the same things, right? The shell parses and interprets line by line, whereas compiling parses and interprets an entire file. So it's all leading to the same place. We get input from the terminal, we read it into the string, and then we parse that one line and we interpret that line. Now let's see the parser. The parser is pretty much the same as in my previous videos. Every single line is still an expression. Now, this is pretty similar to the pest book, how they show how to use pest. They do like a copy or a simple implementation of the J programming language, which is like an array-based language where everything is a expression. Every single line is technically an expression. I've modified a lot of their stuff, but anyway, so every line is an expression, so that's the only rule we really have to worry about. And we know every line is an expression because each program is some number of statements, and a statement is just an expression, right? So if we go to this function, build AST from expression, right, we have all of these rules that we're matching on. Right, and actually let's just scroll up all the way over here. Monadic verbs are just things that only take one argument, right? Like the rank or the row reduced echelon form or the inverse, right? Dyadic verbs are like the dot product, matrix addition, multiplication, etc. Our AST nodes basically are the lines and stuff inside of the lines because it is a recursive type. So like I could have a monadic op inside of a monadic op. I could have a monadic op inside of a dyadic op, right? And our matrix is constructed of terms, where a term is just like a list of numbers. So if I go up here to Z, right, one term is 431, right? Or is it 4? It's okay, it doesn't really matter. That was from the summer, I don't really remember it all that well. And then a command is just a tuple of the command string, and then a vector of other strings, right? So, let's go back down to build AST from EXPR. This hasn't really changed, honestly. If anything, you can watch my previous videos where I explain this in more detail. I don't want to waste time like double explaining things because I don't think any of this has changed really. So let's exit this. What else is this called? Then this calls interp. One last thing before we call interp, I have added some things, namely traits to my Lala type. If you remember, the Lala type can either be an integer, a double, or matrix. I guess I will have to add functions into this because I also want my language to have first class functions, so I can like store a function in a variable, just like you can do in I think Rust, and I think, well, I know languages like OCaml, Erlang, and any of the ML languages, stuff like that. So yeah, I've only really added 2 traits here for the monadic verb and the dyadic verb, just a 2-string for each of them. So that when I print it out, I can actually just do the verb dot 2-string. And I've also added the clone trait to my Lala type. That way, we'll see in a second, when I did like let b equal a, it's basically just cloning the matrix. And I didn't have to implement that at all. I'd actually just do dot clone. So now it's the actual fun part and the interesting part of all of this, the interpreter, right? So let's, we're already here. Why is this here? I don't know, whatever, it doesn't really matter. This is mutable because in all of the functions I am changing the environment. Anyway, so we iterate over the entire abstract syntax tree, and for every single node in them, we determine if it's an assignment, monadic or dyadic op. If it's an identifier, we just print out the value stored in the environment of that identifier. And then if it's a command, we evaluate the command. So let us, eval assignment hasn't changed like at all. I think if anything, I just made it a little bit cleaner, the code, but it does the exact same thing because I haven't really changed anything about this. If I'm doing like let a equal some matrix like I do here, right, like with z and this thing, then I just construct the matrix. I just go over all of the AST nodes, because remember the AST node can also be an integer or a double. So I go over all the AST nodes. I guess I should, oh I do, I check if it's not an integer or a double and I just, you know, throw an error. But otherwise, everything is actually stored as a F64 in my language. So yeah, that's just like a fun fact, I guess. So that's construct matrix. Monadic op, then I just evaluate the monadic op, we're going there soon. Same thing for dyadic op. And of course, I just store it in the environment, right? Eval command, I have my own file for the commands. So let us check out eval monadic op, right? This is where the code got significantly cleaner, because I don't know why, I was doing this in every single match case for some reason, and I can just take it out of the match, and then just boom, I put it in there, right? Because for the monadic op, I'm only doing matrix things, right? So what I can do is get the matrix from the environment, right? Because eval expression up here, if it's an environment, if it's an identifier, right? If I'm doing like det of z, right? I want the determinant of z, then I get the value out of the map of the environment. But if I'm doing like det of some monadic op, then I just evaluate the monadic op first, and then I do the determinant. Same thing for the dyadic op. If I'm doing det of like a literal matrix where it's the numbers separated by semicolons, then I just construct the matrix, return it, and then if we go back down, I let my matrix equal whatever the result is of this. And again, eval expression should pretty much always be, for now at least, a matrix. And then based on the verb, I just call the function that I need, right? In matrix.rs, I have all these functions. This is what I wrote over a year ago at this point, I think. My most popular YouTube video ever, the linear algebra library in Rust. If you are here from that video and you haven't been keeping up, I actually have changed a lot of stuff with those functions, where, for example, well, first of all, I was passing everything in as like a mutable reference, and I was literally changing the matrix in like half the functions, and other functions I was returning the matrix. I don't know why I was doing that. That's just bad programming, right? But I changed it to where If I'm returning a matrix, I just make a new matrix and I return the new matrix, and that's it. Yeah, I mean, don't really have much to say about that. I just call the method that I need for the matrix. Dyadic op, literally the same thing, right? Dyadic would be like a dot product. I have A dot B, or in our thing, it's M at sign N. So I get the left side from the environment, or I just evaluate it, right? If it's a literal matrix, it's a literal matrix. Eval expression takes care of that. I evaluate the right side, and then boom, if it's a dot, I do left side, dot, right side. For some reason, oh, yeah. So basically, I don't know why the dot clone was in there. No idea why, but here we're saving some time, right? As the matrix gets significantly bigger, let's not, waste time and memory cloning it over and over again. So I think that was left over from the way I used to have it, and somehow I was getting like a reference to a matrix and it was throwing some problem. But anyway, plus, right, I combine with this little function here. I have combine, right, because combine can do anything I really want it to do with two matrices. I could even apply some function on matrices. And in fact, if I ever want to do like a monadic operation, or no, I guess this would be dyadic, but I'm like scaling it. So it'd be like, instead of matrix multiplication, it'd be like 2 times some matrix. I could do combine with an identity matrix of the same dimensions as the matrix I'm using, and then I can just scale the identity matrix by that scalar. Yeah. That's pretty much all I wanted to say about that. We already went over eval assignment. Oh, my commands. Here we go. This is fun, right? So eval command, if it's link, I do the link command. Otherwise, I do the debug command. So here, right? Debug, like I said, is just printing the environment for now. Eventually, I am actually going to do something different. Link, right? For all the files I list, right? When I do /link f1.lala, f2.lala, whatever, for all the files, I interpret them, but the shell has its own environment, right? And of course, link can also be used inside of a file. But anyway, the shell has its own environment. I talk about everything in terms of the shell, because the shell is, in my opinion, which you could argue my opinion is the only one that actually matters, since this is my project. The shell is the intended use for this project, right? You can use files and compile them, but the way I plan on using this is pretty much exclusively through the shell. It's just for quick and easy matrix things. So the shell has its own environment, as does every single other file. So what I can do, I can pass into interp my environment as an option, and basically it's going to be adding to the environment for every single file. Hopefully there are no repeated values in the file. I do have an idea right here, we can see where I pass in the file name and I can append it to the beginning of the var names, right? So if I do something like /link, I don't know, example, no, let's just not worry about that. Let's do /link file.lala, right? Then vars in file.lala would be exported as maybe file this A, right? Where A is defined, oops, in there, right? Just an idea. For now, I don't do any of that. For now, I just dump the stuff in there. But then doing this, I don't need to pass in any like Boolean as to whether or not I'm linking. I could just pass in an empty string, because Obviously, appending an empty string to the beginning of the file isn't going to do it. To the beginning of a variable name isn't going to do anything. And then in interp, I can pass the file name into every assignment. And then in all my assignments, when I insert something in, I can just do like the string append with the file name and then the identifier after whatever kind of delimiter I want. If I actually want these 2 colons, which I'm not really a fan of, or a dot, which I am slightly more a fan of, I don't know. I don't know what I'm going to do yet. But yeah, that's pretty much it for that. So yeah, I think that covers pretty much everything in my interp and with my command file. So yeah, let's just play around with it a little bit more before I finish recording. Right, if I do let a equal 1 2 3 6 7 8, oh, if I do 9, it's gonna have a determinant of 0, which is slightly less fun. So let's do 0, right? If I do det a, boom, 27, and I'm pretty sure that's right. Yeah, if I do like inverse a, boom, right? I mean, I'm definitely going to work on like printing the things a little bit better, right? But I'm not even sure what I really want to do anymore. I was thinking maybe like some autocomplete stuff where if I'm doing example dot whatever and I press tab, it like, auto-completes my stuff, but well, what the heck. But that's just like a fuzzy find over the directory that I'm currently in, or if I already have a string right before it, it's a fuzzy find into that directory of all the files. I don't know, right? I mean, it's just an idea. But yeah, that's pretty much it for the project progress, I suppose. Made a lot of crazy progress over the last 2 days, and I guess now is a good time to talk about like the state of the channel, maybe. Yeah, I didn't do a lot of work on this over break. I wanted to, but I don't know, I just didn't end up doing anything with this. I took a web dev course at my school, and I really liked it. And I kind of want to do like some web dev projects now. But yeah, I might do like a web dev project after this. An ideal project would be some sort of like online D&D thing with your friends. Like fully text-based. It's not going to be like Baldur's Gate 3. Not even Baldur's Gate 1 for that matter. But it's going to be like completely online. I might even make like a mobile version. That's pretty much it. I have some other ideas for projects lined up, but that's really it for me. This semester is my last. I'll try to upload some more, but if I do, I do. If I don't, I'm sorry. But I'm definitely gonna try to, because I do like uploading. Yeah, I don't really have anything else to say. I think we're good. But yeah. Hope you guys like this video. Oh, if you guys have any like questions about the code, you can comment, which a lot of you guys already do. If you guys have any like suggestions to what I can add, that'd be really cool, right? Because I do want to add stuff to this besides the functions. And honestly, I'm not really into adding the functions. I don't know how I'm gonna... I have an idea of how I'll like handle doing the functions, but I don't know. I'm not sure what I'm gonna do. If you guys have ideas for what I can add to this, if you guys have ideas for projects, right? If it's something that you think I can do, it'd be fun to see, right? I do want to make like a compiled language. This was fun, the interpreted language, but there comes a point where it's not really like I'm working on my language anymore, but rather that I'm working on like a interpreted language, which is really just working in Rust. I'm just doing a Rust project then. When I'm working on like a compiled language, which I have done for a class, that feels like pretty much all the time I'm working on a compiled language. In fact, the reason I was late with this video is because I was working on extending a compiler that I made last year in my last spring semester. I was adding like go-to labels and break statements and continue statements because we just didn't do that. And even though it's all very like high level, it's not like anything low level in the compiler. Break, continue, and go-to labels are all control flow and can all be handled with the front end, really. Like there's no assembly needed for that. I wanted to add the ternary operator, and that is looking like I'm gonna have to do some lower level stuff with like the assembly, so that way I'm able to actually retrieve the result of whatever's inside the if statement in the ternary operator, so that I can store it in whatever I'm like actually storing it in, if that makes sense. But because like at this point in time, I thought I could just do like an if statement, but my if statements don't like return like they do in Rust, for example. Like if statements can return things to a variable, but you know, we can't do that in my language right now. But yeah, I want to do a compiler. Not sure when though. I'm not sure how. Could do it from scratch, or I could just do like an LLVM tutorial, basically. I don't know. It is what it is, right? But yeah, if you guys liked the video, if you guys made it this far to me rambling for like, I don't even know how long it's been. How long has it been? 20 minutes now? If you guys liked the video, you know, give it a like. If you guys want to subscribe and hear more about me write bad code, do that, subscribe and stuff. Share with your friends, share with your grandparents. I don't really care. But yeah, thanks for watching.